Okay, for number 3, we're going to be using product rule. We're going to be using product rule. Now remember, with product rule, you're going to follow derivative of the first times the original second plus the original first times the derivative of the second. Okay, so we have two things being multiplied. That's the rule we're going to follow. So we're going to go one by one. So we have two things being multiplied, x squared times 3x minus 1. So when I take the derivative using product rule, derivative of the first one, 2x, leave the second one alone, plus now derivative of the second one. The derivative of 3x is 3, the derivative of negative 1 is 0, times the original second one. So when we clean that up, that's the derivative. Now we're going to clean it up. Distribute the 2x, we get 6x squared minus 2x plus 3x squared, 6x squared plus 3x squared. That would give you 9x squared minus 2x. Okay, so for all of these, derivative of the first times the original second plus original first times the derivative of the second. Okay, next one, and again following that order, slowly, carefully, derivative of the first. The derivative of 5x raised to the raised to the 0.5 would be 2.5x to the negative 0.5. The derivative of negative 3 is 0 times the original second, which is 2/3 x to the 6 minus 5 over x to the third, which you may want to rewrite as minus 5x to the negative 3. That would be a little bit easier when we're taking the derivative, and when we're trying to clean that up. So minus 5x to the negative 3. Then remember it's plus the original first one, 5x to the 0.5 minus 3 times the derivative of the second. So the derivative of the second, 2/3 times 6 is 12 over 3, which is 4, x to the fifth, minus, now remember we're going to use the minus 5x to the third, x to the negative 3, so negative 3 times negative 5 is plus 15, subtract 1, negative 3 minus 1 is negative 4. So first of all, make sure that we've done the derivative correctly. Make sure we did the derivative correctly. And then we're going to clean it up, but that's the derivatives. Now, when we clean it up, we're going to distribute, and we have 2.5 times 2/3. Again, we can use the calculator. 2.5 times 2/3, second mode. So we have 2.5 times 2/3. That gives you, enter, 1.66666, math, number 1 for fraction. That gives you 5 over 3. So that would be 5 over 3. Then we have x to the negative 0.5 times x to the 6. When you add that, so that's x to the 5.5. Then we have 2.5 times 5. So 2.5 times 5. 2.5 times 5. That gives you 12.5. So that would be 12.5x, and then you add the exponent, so x to the negative 0.5 times x to the negative 3 would be x to the negative 3.5. Then here, we're going to have a lot of distributing going on, so we're going to have to do 5 times 4x to the fifth. That one's going to be 5 times 4 is 20. Add the exponents, x to the 5.5. 5 times 15 is 75, but again, if you need your calculator, 5 times 15 is 75. So that is plus 75. Add the exponents, x to the 0.5, x to the negative 4 is x to the negative 3.5. Distribute the negative 3. Negative 3 times 4 is negative 12, x to the fifth. Negative 3 times 15 is negative 45, x to the negative 4. So again, simplifying, algebra. Now we're going to combine like terms, and generally we start with the highest exponent and work our way down. So notice we have 5.5, so we can put the two 5.5s together. And if we did 5/3 plus 20, that's 20 and 5/3, but we can put that in the calculator. Parenthesis 5/3 plus 20. That gives you 21.6666. If you hit math, number 1 for fraction, that gives you 65 over 3. So that's 65 over 3, x to the 5.5. Then we're going to do the 5, which is minus 12, x to the 5th. Then we have negative 3.5, negative 3.5. So we're going to do negative 12.5 plus 75. Negative 12.5 plus 75. That gives you 62.5. So that is plus 62.5 x to the negative 3.5. And then we have the minus 45 x to the negative 4. That would be a complete answer. That would be a complete answer. But I'm going to go ahead and clean it up just a little bit more by making all the negative exponents positive. So my final answer for the derivative would be 65 over 3 x to the 5.5 minus 12 x to the 5th plus 62.5 over x to the 3.5 minus 45 x to the x over 45 over x to the 4. Okay, be careful, be careful, be careful with the cleaning up, with the simplifying. And then the next two involve some special cases. We can add special cases in as well. So again, we have two things being multiplied. X squared times e to the 3x minus 4. So the product rule says derivative of the first one, derivative of x squared is 2x times the original second one, e to the 3x minus 4, plus derivative of the second one. Now how do we take a derivative in e? Rewrite it, e to the 3x minus 4 times the derivative of the exponent, derivative of 3x is 3, derivative of minus 4 is 0, times the original second one. Then I'm just going to rewrite it, so we have 2x e to the 3x minus 4, plus, I'm going to put that 3x squared in the front, looks a little bit nicer, to the e 3x minus 4. Now, I can leave it like that. I could factor it if I want to, just make it a little bit simpler, but I would accept the answer just like that. If you did want to factor it, you can. It's the same answer. You can pull out an x, you can pull out an e 3x minus 4. If you did that, you're left with 2 plus 3x. Both answers would totally be correct. Both answers would totally be correct. Okay? For the last one, again, we have a special case in there. So we have two things being multiplied. We have ln of x to the third minus 2 and 5 raised to the 3x. So both of them are special cases, but if we follow product rule, derivative of the first one. Derivative of ln x to the third minus 2 would be 1 over x to the third minus 2 times the derivative of x to the third is 3x squared. Derivative of minus 2 is 0 times the original second one, 5 raised to the 3x, plus the original first one, ln of x to the third minus 2 times the derivative of the second. Now remember, derivative of the second, how do you take the derivative of a number raised to a variable? It's rewrite it, 5 raised to the 3x times ln of the base, which is 5, times the derivative of the exponent. Derivative of 3x is 3. Now this I'd probably just rewrite to make it look a little bit nicer. So maybe have 3x squared over x cubed minus 2 times 5 raised to the 3x plus, there's really not much you can do, but I can put all those in front. So for example, I can say 3 times ln of 5 times 5 raised to the 3x times ln of x cubed minus 2. It's a little bit nicer in that order, but either way is fine. Either way is fine. But that'd be product rule, but also adding in those special cases. Adding in those special cases.